Hey class, this is Lieutenant Commander Streetpack. We are at the jet log portion of your studies, and this is one of the take-home examples that we are going to cover in this video. It's the Big Brown Creek scenario. So you should have gotten this. If you didn't, maybe you haven't taken this class yet. But when you do, you'll get this scenario. These three different lat longs for Big Brown Creek Airfield, Huntsville, and then Cimarron. Saying they're all airfields, just to give you a heads up on your new version of your chart, they did remove a lot of the old not used fields, and Big Brown Creek and Cimarron are both um, out of date fields, and so they're not going to be on your new charts in your version 16. Not a big deal. We'll just use the lat longs that are provided for us and use those to do the scenario. They give you a pre-flight planning information. So they give you takeoff information, fuel load. So that's what you start with for fuel. Fuel flow, true airspeed, pre-flight winds, and then they give you the in-flight scenario too. This video is only the pre-flight, so if you need to, go to the other video for the in-flight scenario. Okay, so we're only going to talk about just set yourself up and then doing the pre-flight stuff. All right, so when you get started, this is during your dump sheet time, which we don't want to do, is get ready by maybe doing a little bit of gouge. Okay, so you have an actual time to take off. You don't need to worry about this stuff here because there's no flight to your first point. So we do know that we got. We'll put our points in there in a second, but this stuff is always going to be done during your dump sheet time if you want to. True airspeed, fuel flow, and wind. Okay, you don't have this stuff during the dump sheet time, but when you do have it, you know where to put it. Okay, you also want to do pounds per minute. Okay, that's what that stands for, and nautical miles per minute right here too. And you're just going to use nautical miles per minute. You're just going to use your true airspeed to do that one. Although it may not be that accurate, it does give you a first look at what the winds or what you're going to travel about. Okay, pounds per minute will stay the same the whole time because your fuel flow stays the same the whole time. No, true airspeed does as well, but when you're doing your ground speed calculations for your ETEs, it's going to change per leg, right? So we know that. So we know it's going to be this is more of a rough estimate versus the estimate you can take after you get your ground speeds. You notice I'm splitting my times up, because you want a decimal minute, and then you want the actual time. Also, these times down here are going to be estimated time of arrivals, so we're not going to need the actual time of arrivals for that. Also, estimated fuel remainings are going to be there. Okay, so first point, second point, third point, 2 legs, note section, you're good to go. We know that there's going to be a headwind or tailwind component, so that's going to be right here. You're going to have a crosswind component. You're going to have a grab angle associated with that. So crosswind, grab angle, and we know it's going to be headwind, tailwind, and we just circle it and write it out. Or you just write the number and then a headwind, tailwind next to that. Resulting true heading and ground speed. So this note section is mostly for your pre-flight wind calculations. In fact, that's what it's for. So true heading and ground speed for both legs. Cool. Next, you'll have your in-flight scenario, and they'll give you that. So you don't need anything for this one except maybe you just want to put your actual numbers again here, so you can do that. And then in-flight wind. Okay. Then you're going to have your fix. You're going to write the fixed information and then the second 2 legs there. So the course control navigation here, followed by the second leg. Okay. We know that this one's going to be an actual time of arrival. So we'll do that. This could be an estimated fuel remaining. Doesn't matter. Or actual fuel remaining. Who am I kidding? So we'll go ahead. The actual fuel remaining for that one, estimated for these, because as soon as you have a fix, you're going to estimate the rest of your legs. So this is again going to be headwind, tailwind. I'm sorry, this is the fixed stuff. So this is going to be your in-flight wind calculation information here. This is going to be crosswind, crab angle, crosswind, crab angle, true heading, ground speed, true heading, ground speed, and then everything else is ready to go. So that's how you're going to gouge it before you start the exam. Now, once you get the exam, all right, they're going to give you this information, and so go ahead and put the points in here. Big Brown Creek, Huntsville, and Cimarron. Okay, there's the fix. Okay, they tell you with the fix in the in-flight section. So you're at a 784-foot tower. Okay, and then you want to get back to Huntsville and Cimarron, so you write those in here. Cool. All right, so those are in there, and then the other givens you're going to want to put in there as well. So switching it up, because in the note sections here we had takeoff time, so 2000, 0 seconds. Fuel load is 2000. Fuel flow 760. True airspeed 275. Winds 184.55. Cool. Pounds per minute, we can do just divide it out using the rule of 60. I got 60 times 10 would give me a 10 pounds per minute. That's 600. There's more than that. It looks like there's at least two more, maybe three. So for an estimate, maybe use 13. Okay, for pounds per minute. Nautical miles per minute, you just take this number, maybe round it down or up, depending on what you want to do. So 25 knots to get to 300. So that's a 5-to-1 ratio. 5 nautical miles per minute. Cool. So I have that, and now we're ready to go. I got everything. We just need to start plotting points and doing a pre-flight wins for a pre-flight section of your jet log. All right. So we look first for these lat longs. 3149.8. Okay, so find your reference lines. Here's 31 down here. 3149, so you gotta go to the 30-minute line. 49.8 all the way up here. We'll move this down a little. Cool, so it's close to 50. So we'll go do that. All right, cool. I got the line there for it. And now I'm just going to double check something real quick because I don't know where to draw my line. 9603.2 is where the other side is. So let's look for our reference lines again. We have the 31 reference line was right next to 95, which is off the there it is, 95. So then you go to 96, which is actually two lines over. There's one, there's two. So there's the 96 line. So, and then since my straight line's here, it's going to be over here, 96.03, 0.2. So then it's going to be here. Well, I've already kind of done this work for you, but yeah, for the first one, you're just going to line this up to the straight edge, make sure there's, 3149.8 is lined up there. You draw your straight line, and then you do the same thing with longitude. You find your 96, 3 minutes, 0.2, and then when you're confident that's your line, you draw your straight edge, and then you look and see where the intersection is. Well, there's a smokestack there. I'm sure there's an airfield that was close by there at some point, so that's our point. Okay, the next point was Huntsville Airport, located at 3045, 9535. So 3045 is more south, so we're going to roll this down here. So 3045, the reference, there's 31. So 3045 is above the halfway mark. So there's the halfway mark. So it's somewhere over here. Oh, I've already highlighted an airfield that says Huntsville. Okay, let's make sure that's it. So 45 is like right around here. Tell. Awesome, cool. And then 9535. So this is my 95 line right here. You can see it. So this is 30, 31, 32, 33, 34, 35. Hey, what do you know? Huntsville, this is my point. Okay. Now, if you notice my my intersection line, I stopped at latitude. It was a little high, but again, when we find our airfield, we just use the center of mass. So that's where I'm always drawing from. Okay. Great. If we had airfields for the other points, then we would use those center of mass as well. We don't have it for this chart, so we're not going to do that. But the last point, which I found already, was 3008.7. and 95.57.7. So it's even more south. It's right above the 30-minute line. Here it is, and 8 minutes. So it's up here, and then 95.57. So almost 56. So here's 56, and then you back it off almost 3 minutes, which you don't. It's not quite up there. It's like 2.3. And so there you go. There's my intersection. I have my point. I mark it. Now I have all three of my points. Once you have all three of your points, again, continuing on from the chapter 2 stuff we learned, we draw a straight line from our first point to Huntsville. Okay, so Huntsville's off. So both points are off right now. You can't see them, but basically, like, you're gonna draw between the 2 points. Okay, make sure it's nice and straight line. You draw it. All right. From that point on, what you want to do is you want to put your dividers on the 2 points if you can do it. But a lot of times, what happens, like in this scenario, I'll move it down just so you can kind of see. But I'm going to go ahead and twist this all the way out, okay, as far as I can get it. I'll put my first point down on the smokestack, put it all the way down here, and guess what? The point is not on Huntsville. I still got some more distance to go. Okay, so I don't want to use this distance unless it's a known value. And so what I'll do is I'll find a known value, like 30, because that's between these two lines here. Measure that. Now I do it again. This time it's called leapfrog. So put 1 point down here, leapfrog it down here, and then leapfrog it again, get the remainder. I'm sorry you guys can't see that, but we get the remainder here. There it is. And then we measure it, and whatever that remainder is, that's what we're going to use for our scenario. So for this scenario, let's make sure I didn't get a different distance. But yep, there it is. So 95, or so I got 9.5 DME after 2 leapfrogs. So that's 30, 60, 69.5. So I'm going to write that down right here. 69.5. Okay. Then I'm going to go ahead and measure my course. I can use these 2 points again, whatever I feel like, as far out as I want to, and that just holds my 2 points down to help me with direction. So as I'm moving this up and down, it'll help me measure my direction. Okay, I'm going to use a latitude line this time. I'm going to have to use the bottom scale, and the reason why is because I'm looking at a southeasterly direction. So I know the bottom scale is the south direction, and maybe it'll give me exactly what I need. So there's the intersection there. I look out and it's on this line. It says 070-250-340-160. The right scale would be the southeasterly direction. That's 160. So I'm going to mark that off. Okay, that's my true course. All right, and then I'm also going to do the second point as well. Again, so put your divider down on both points. This time it's a shorter leg, and I can get both of them on there. I'm going to flip this thing over. I'm going to use my latitude line again, or maybe I'll use a longitude line this time. No, I'll use a longitude line. Okay, I'm going southwest now. So I'll use the second scale. So instead of, what it says there, close to 030, I'm going to use the one that's below that, or 210. Looks like 211 maybe? Let me just double check that. I might come off the screen for just a second, just so I can double check. But if my math is good here, oh my goodness! So I did it. So I did exactly what I said not to do. I did not bracket. Okay, so maybe some of you guys are like, well, yeah, sir, it's 210. It's 2, and it's a little bit less than that. It's like 2. It's on the 2 off. But I'm not bracketing. So if I bracketed, I would have found I was between 210 and 200. So I'm not counting up. I'm counting down. It should be 208. That's the direction. Okay, so yeah, I'm an offender too. So um, just bracket. If you bracket, you don't miss out. Luckily, I just caught myself, so that's good. Always want to double check all your work. Measure twice, cut once, right? All right, then you measure the distance. Distance is 41 nautical miles. I'll go ahead and write that in there. And now we're done with measuring courses and distances, and now we're ready to start on our pre-flight wind calculations. Okay, so for this, um, pull out your whiz wheel, all right? Flip it over, all right? We're gonna do shorthand pre-flight wind calculations. This is, if I need to, I'll write stuff down. I write information in my notes section, and but I'm gonna do my quartering analysis on the whiz wheel. As long as you do this correctly, as long as you're putting your numbers in the right spot, you will never have to use the WinT, only if you're doing actual quartering analysis for the test. And I would totally do WinTs for that. All right, so 275 is my true airspeed, 260, 270, 275. Perfect. Okay. And then I turn in my winds. Sorry, winds 184 at 55. Let's erase these old marks. 184. 55. I can tell I used to have a point there. Okay, got it. All right, and then I turn in my first course. Okay, so first course is 160. It's just a little bit to the left. That means my quartering analysis, my heading's going to be to the right, because I got a crab right, and I have a headwind. And I have a headwind about 50 knots. So headwind 50, crosswind looks like 22 knots. Okay. Now you're like, okay, well, what do I do with 22 knots? I remember something about estimation. Yeah, you can estimate your crab angle using the 10% rule. So there's 5, 10, 15% rule. And remember that 10% is 6 degrees. 10% 6 degrees. And then from there, you can do the 5% rule, or you can do the 15% rule. 275, 10% of that is 27 and a half. Half of that would be like half of 28, so that's 14. And then just add 14 to 28. That's 42. Just subtract 141. Okay, that's a good estimate there. All right, got 22 knots. That's less than 27. I have less than 6 degrees of crab. Okay. All right, so now we find 22. Look down. Okay, you're between 4.5 and 5, so you're going with 5. And that's right crab. Okay, right side, right crab. That means you add it to our course. 165. So 160 plus 5 is 165, or 165. And then also you want to do something with this 50. Since it's a headwind, you'll subtract it from your true airspeed. And so 275 minus 50, 225. Cool. All right, we're done with the first one. Now we go, we have the same winds. Winds are the same, true airspeed's the same. So we can go straight to 208 on the course. Okay. And from there, we look at our dot. And I had that little eraser mark before. It gets my eyes right there. It looks like another 50 knots of headwind. So headwind 50. Okay. So again, we have 225 knots of ground speed. Now we just have to find crosswind component. And this is really weird. It almost looks exactly the same on the other side. So now it's left 22, which is still 22 is still 5 degrees. There's 5 degrees left. Cool. So instead of adding 5, now we're going to subtract 5 from the new course. So 5 minus 208. All right. Now we're done with pre-flight winds. Chapter 5 is done. All right. So now what's next? Well, there's blank space here. It says ETE, estimated time of route. So this is like ground speed equals distance over time. So we take this ground speed and this distance, and then we'll find the time. Okay? So 225. Oh, gotta use the other side. We can estimate 225 is close to 240, right, for the roll of 60. So it's about a 4-to-1 ratio. So if we divide 69 divided by 4, that'll give us an estimate for our time. So 69 is close to 68. 68 divided by 4 is, I don't know. I'm trying to figure that out, but it's like, let me think here. So 15 would be 60. So plus 2 more. So 17 minutes. 17 minutes is my estimate. Yeah, it gets hard, doing this mental math. So try to do enough just to be able to get an estimate. So looking at something like 17, 25 to 25, boom, done. And that's actually going to stay for both because both of these legs have 225 for ground speed. So I can keep that there. I'm just looking for different distances. So 69 nautical miles for the first leg. There's 69 and 69 and a half. There we go. And look at that, 18 and a half. We estimated 17, it's 18 and a half, close enough. All right, so what's a half a minute? It's 30 seconds. All right, let's do the second one. So 41, look down, it's 11 minutes. All right, now you have your ETEs, estimate your time. So you're going to add it to 2000. 20, 18, 30, and 20, 29, 30. Cool. Done with ETEs. Now this blank space is leg fuel, so fuel flow is over here. So we did about 13 pounds per minute. This may be, difficult to do, but if you round, it might be better. So 18 is close to 20 minutes. 13 is close to 10, and we rounded up for this, down for this. It's great. 20 times 10, 200. So this is going to be close to 200. We know this is about a little over half of that. So this is probably like 150. It's going to be less than 200. Sweet, that's all you need to do. So 760, wherever that is. Where is that? Cool. There's 700, there's 760. Cool. Got it. So now, 760 pounds set. We just look for time. So 18 and a half. So that's denominator. 18 and a half is right there. 18, 19, 18 and a half. Okay, so that gives me between 200 and 250, 210, 220, 230, 234 pounds. Okay, next leg, I got 11 minutes traveled, same fuel flow. I got between 13 and 14, one tick mark off, and they're all 0.1, so 139. Cool. Done with my fuel legs. Now I just subtract 234 from 200. The first one is going to be 1766. And then 166 minus 139 is 1627. All right. And that is, my friends, the pre-flight wind calculation in a nutshell. It was 24 minutes. The in-flight's about the same, a little bit longer. So you're looking at having to do this in about 50 minutes if you're doing 2 legs. If you're doing 1 leg, which for night first, you're going to be doing 1 leg, then you only have, maybe it's 5 minutes less or 10 minutes less or something. So just keep that in mind. You're definitely going to want to give yourselves at least 50 minutes to do this. All right. Do the in-flight stuff when you're ready. Just be squared away here in the pre-flight. Have a good one.